Thank you for coming to this session. Today, I will present our study, Mobile Accessible Seamless Agent, or MASA. The main idea is very simple. Educational chatbots should not answer freely from the whole internet. Instead, they should be grounded in teacher-provided course materials. In this talk, I will first explain why hallucination is a serious problem in education. Then I will introduce ChatbotLLM and MASA, explain how the system works, and finally present our evaluation plan. My focus is not only on technology, but also on teacher control, curriculum fidelity, and trustworthy learning support. Let me begin with the motivation. In higher education, conversational AI has become very attractive because students can ask questions at any time and receive immediate feedback. This is especially useful when teachers cannot answer every question individually. However, the same strength also creates a serious risk. A chatbot may give an answer that looks fluent and convincing, but the content may be wrong. For ordinary chat, this may be acceptable. But in education, students build knowledge based on these answers. If the chatbot gives wrong concepts or fake citations, it may mislead students. Therefore, our key question is how to make educational chatbots more trustworthy and more controllable by teachers. Next, I will clarify what hallucination means in this study. Hallucination does not simply mean that the model is creative. It means that the model generates information that seems reasonable, but is actually wrong, unsupported, or logically inconsistent. One important reason is that large language models are not databases. They do not retrieve truth directly. They generate the next likely word based on patterns learned from large-scale text. This design gives them strong generalization ability, but it also creates a trade-off. The model can make fluent answers that go beyond reliable evidence. In education, this is dangerous because accuracy, evidence, and reasoning are fundamental to learning. Many approaches have been proposed to reduce hallucination. Prompt engineering tries to guide the model through better instructions. Fine-tuning adapts the model using additional training data. Grounding connects the model to external knowledge sources. More recently, the trend has moved toward hybrid approaches, which combine external grounding, process control, and self-consistency. However, in educational settings, two problems remain. First, retrieval may bring in noisy or irrelevant information. Second, teachers often cannot control the system in detail. Therefore, our design direction is teacher-grounded and teacher-configurable. The chatbot should answer based on approved course materials, and the teacher should decide how much generative rewriting is allowed. Our proposed solution has two connected parts. The first part is ChatbotLLM. It works as the service provider. Teachers upload course materials, such as PDF, PowerPoint, Word documents, spreadsheets, scanned files, images, and even audio. ChatbotLLM prepares these materials and builds a searchable knowledge base. The second part is MASA, which is the learner-facing client app. MASA is browser-based and mobile accessible, so students do not need to install a special application or go through complex login steps. The most important principle is that the chatbot should not answer everything. It should answer from teacher-provided materials. If the system cannot find relevant content, it should honestly say that it does not know. This slide shows the architecture. ChatbotLLM has a three-tier structure: the presentation layer, the API orchestration layer, and a logic layer. In practice, the teacher first uploads course materials. The system converts the files into text, extracts useful content, and prepares a vector index. When a learner asks a question through MASA, the question is encoded by a sentence transformer. Then the system uses cosine similarity to find the most relevant paragraphs from the teacher-uploaded materials. Depending on teacher settings, a large language model, such as Gemini, may be used only to rephrase the retrieved content or support RAG. This means generation is constrained by the course materials rather than open-ended knowledge. Now, let us look at MASA from the learner side. The design goal is seamless access. Students can open MASA in a browser, including on a mobile phone, and start using it with very little friction. The landing page is clean, and students can directly start a chat or continue from recent conversations. After that, they select the subject they want help with. Even if a subject is visible to the public, teachers can still use an access key to protect uploaded materials. This design is important because if a system is too complicated, students may not use it. MASA tries to make trustworthy AI support feel as simple as an everyday messaging app. This slide shows the most important practical behavior. On the left, the learner asks a course-related question. MASA retrieves relevant content from the uploaded materials and provides an answer. On the right, the learner asks a question that is not supported by the course materials. In this case, MASA does not try to be helpful by inventing an answer. It clearly tells the learner that the provided context does not contain the answer. This is a small design choice, but pedagogically it is very important. In education, saying, "I cannot find the answer in the provided materials," is much safer than giving a fluent but unsupported response. Because this paper mainly presents the system and a plan validation, we also designed a comparative experiment. We plan to recruit 60 university students from similar disciplinary backgrounds. They will be randomly assigned to an experimental group and a control group. The experimental group will use MASA with ChatbotLLM, where answers are grounded in teacher-approved textbooks and academic literature. The control group will use MASA connected to an unrestricted large language model. The tasks will include knowledge comprehension, citation-oriented tasks, and reasoning-based tasks, because these tasks are more likely to reveal hallucination problems. We will compare hallucination rates, hallucination types, severity, satisfaction, and learning outcomes. To conclude, MASA is designed to make educational chatbots more trustworthy and easier to use. Its first contribution is the teacher-grounded knowledge source. Instead of relying on the whole internet or only on model parameters, the system answers from teacher-uploaded and verified materials. Its second contribution is configurable control. Teachers can adjust retrieval settings and decide whether generative rephrasing or RAG should be used. Its third contribution is accessibility. MASA works through a browser and provides a familiar chat interface, which lowers adoption barriers for students. Our next step is to conduct the planned comparative experiment and empirically test whether MASA can reduce hallucination while maintaining learning outcomes. Thank you very much.